Hey there, it's Shannon Matchick-Myers, and today we'll be taking a look at finding the least square solution of a system, a times x equal to b, using elementary linear algebra, so using matrices. Now, the trick here is we basically need to find the normal equations of the least squares problem, which is a times x equal to b. Basically, what's happening here is a times x, I won't go too in depth because I have a whole video on this, minus the vector b ends up belonging to the row space of the orthogonal complement of a. And what does that mean? Well, the row space of this orthogonal complement of a is equivalent to the null space of A transpose. We can write that A transpose times this quantity, A times x minus b, is equal to the zero vector. And then from that, which in turn will give us with some algebra that A transpose times A times x minus A transpose, that b is a vector there, times the vector b would equal to the zero vector, and then adding A transpose times the vector b to the other side, we're going to get A transpose times A times x is equivalent to A transpose times b. So here we go. With that said, we have our A and we have our B. And so our A transpose will end up being what? Good, it'll end up being what? A 3 by 5. So we'll have 1, 1, negative 1, 2, 1, 0. These are columns. 0, 2, 1. 0 to negative 1, and then 1, 1, 1. We're going to multiply this to A, and A, of course, actually, if you don't mind, I'll just copy A. And that's going to equal to our A transpose. And again, I'm going to be lazy and just copy it. Times our vector B. So B is easy, so I'll just write that out. Good so far? All right, and then, oops, sorry, I forgot the x here. That's what we'll be finding. Okay, very good. So now I'm just going to go ahead and go into Octave and figure these out quickly. Okay, so I'm just going to name everything. So we have A equal to 1, 1, negative 1. And then B So, filling out our equation, we're going to have A transpose times A, and that will be the following. And then we'll have A transpose times B, and we'll get that one. So when I go back, I'll have the following. Times x will equal to 1, 1. All right, so now it just comes down to, we can find that solution, right, by reducing the augmented matrix I'll just call it matrix B. And then we want RREF of B. The RREF of this matrix ends up being 1, 0, 0, 0.14, 0, 1, 0, 0.04, and then 0, 0, 1, 0.25. And notice these are, if you wanted to get them as exact fractions, you would have 1, 0, 0, and this would be 7/50ths, and then 0, 0, 1, 0, and then that one ends up being 1/25th, and 0, 0, 1, 1/4. Okay, the least squares solution of the system would be that our x vector is going to be equal to x1, x2, x3, which in turn is equal to 7/50ths, 1/25th, and 1/4. x1 equals 7/50ths, x2 equals 1/25th, and x3 is equal to 1/4. And that's all the problem called for in this case. All right? So I hope you have a wonderful morning, afternoon, or evening whenever you're watching this show. And if you like what I'm doing, hey, please subscribe. Thanks. Bye.